It was my good fortune to be a student of Chip's, and there's no better way to start a scientific career than to work for somebody who's a pioneer in the field and is very generous with their time. And often you can get one, but not both. And Chip was excellent in both of those. My first encounter with him, however, didn't seem too promising. I've been told that to get into Scripps, I was in the Navy for 5 years, and concerned about whether I was going to get out. I've been told to come to Scripps was like rushing a fraternity. So show up and talk to people. So I did, and I came into Chip's office, and he said, He started counting on his fingers how many years I might be productive and wondering whether it would be worth educating me. So I was rather surprised when I showed up at Scripps and was assigned to Chip. But he was at that point had started the microstructure. Tom Osborne was his first student with it. And Chip after his thesis with Walter, he had been studying internal waves. And he realized that the ocean was not smooth at small scales. At that time, vertical resolution of profiles was probably no better than 10 meters, if that. And Chip's approach was galvanized by the Grant Stewart Moyer paper that verified the Kolmogorov spectrum that came out in 1962. So he then built this microstructure recorder that improved the vertical resolution by over a factor of 100 in one swoop. But he had a bunch of problems to solve with that, and that was what was partly so impressive. He realized that, one, he had to use thermistors instead of the cold films that they had used because he needed much greater sensitivity. He had to drop slowly. He had to drop completely free of the ship. And in those days, that was a gutsy thing to do because this was an expensive instrument, and he was putting his budget for a couple years on the line every time that thing went over the side of the ship. And if the electronics had been relied upon, it would have been long gone. Part of the genius of what Chip did was he made a mechanical release as a backup. It had a brass fracture pin that was set to fracture at a certain depth, and a very intricate system of little steel balls that then released the ballast weight. They would drop it if the electronic release hadn't worked. And he also built a bed spring radio direction finder. I mean, there were no radio direction finders in those days that you could use at sea. And this thing sort of told you, well, it's over here or over there, but it didn't tell you much about any sort of an angle. But with that, he launched into the microstructure and also started wondering, what am I going to do with the data? So he started reading, and Chip was a very fundamental scientist. He'd always go back to the basics. He started reading De Groot and Mazur, which is a classic book of non-equilibrium thermodynamics. And he came up with what was called the Osborne-Cox model and was called the Cox number in his honor. In the summer of 1968, I was at the GFD program at Woods Hole, and Chip was back there as a guest. And he came and presented this model to the East Coast luminaries. And it was quite illuminating. I mean, they did not get it. And Chip presented it in a classical thermodynamic sense, sort of like Carnot might have done, with a little box with a propeller whirling around inside it. And these guys are really rude. I mean, finally they just said, he's an experimentalist, show us the data, forget about this. And I would bet that none of them ever produced a paper that was important and it had the duration of what he started and the way we handled the microstructure data. But it was a very good lesson in scientific humility in not cases of not scientific humility. The other great things that happened with Chip, his time was just wonderful. We spent probably a half an hour to an hour talking every day about all kinds of subjects. He was particularly interested in marine exploration, the history of marine exploration. And in 1972, he sent me off on a cruise to measure microstructure in mid-gyre in the southern hemisphere. And then he took the ship a month later and sailed to Chile. And the ship just happened to pull into Pitcairn on the way by. And in those days, Scripps ships carried doctors. So all the natives came out in their boats to be treated by the doctor. And then when they went back, they did three cheers for the ship. And hearing Chip tell this was one of his memorable times at sea. He then continued on from Chile down to Patagonia, and was out with the Melville looking for Drake's Island. Drake, when he sailed around the world, reported an island off Patagonia that's never been found and presumably doesn't exist. But at that point, the ocean had not been surveyed enough to be certain of that. So Chip was out looking for it and did not find it. And, two of his conversations were really memorable. One was about how the Garrett-Monk model screwed up the notation of wave number and frequency. Because everybody to that point had been using wave number in terms of radians per meter or radians per centimeter. And they switched it to cycles per meter because that was easier to think about. And I certainly liked that and had this conversation with Chip one day. And Chip wasn't buying it. And finally he ended the discussion. He couldn't get it through me why it was a good idea. He just said, "God thinks in radians," and turned around and walked away. The other one that made a really lasting impression on me was when he told me about the need for dynamic incompetence. And that was that if you're asked to do administrative things or things around the house sometimes, you screw them up enough that nobody ever asks you to do them again. And to my wife's great frustration, that was one I really took to heart. Anyway, I had 8 years with Chip. They were absolutely wonderful years with a lot of fun and great insight. It was a wonderful way to start a career. Well, thank you.